there's one by John, which is here's this one here. There is like one where you have things like 30 subjects with 10 scans per, 10 sessions per subject over the course of a month. We have there's like there's one missing in Zulu where there's like 40 sessions of 2 subjects. You know, you have a variety of different designs. We have the NKI, the NKI test pretest with the multiband is in there, which is we had already released that. We patched that in. NYU is giving a new update on theirs. Pure Bellic, Rasmus, various folks have been contributing marvelous. So this year's initiative, where there's actually more data that's also going to be that's just been arriving. So far, it's about 1,500 subjects. The actual now resting scans right now is about 4,400, and actually that's I think low compared. I think it's closer to 5,000 now. And also, if anyone wants to play around with ASL, the site that gave, if I remember right, 30 subjects with 10 sessions per subject, they gave resting state DTI and ASL. With the usual FCP&D rules, what we do is we share all data. Some of it good high quality data, some of it low quality data. In the data paper, unfortunately, I wasn't playing this, so I don't have the figures so easily accessible. But we show things like motion. Of course, it's reliable, and we've seen this at Chaganyana recently in this paper pointed this out, and some of that prior work we showed us too. We're releasing about 0.5, 0.6, and we find in some of the quality controls that you see once again, motion being reliable. So once again, you should account for that. On the site, it's a little rough looking right now, but we do give, we make it where we have in this interface. If you actually see this on the web, I don't know effectively. But we have a variety of different metrics that Kevin Paddock and Shazad have pulled together for motion, functional image quality, anatomical image quality, so forth. We are sharing all those metrics as well. And so this year, I'd say watch for it this weekend, coming out one of the next few days. Like I said, you're going to get it from, if you want the standard kind of tarball version of life that we use, then we have that available on Nitric. There will be, it's like about 138 tarballs if you want everything. So, but they've set up a download manager on Nitric for users and everything. And I was told as of yesterday that was working, but right now it's hidden. And then there's also the communication center. So either one of those two we could pull data down from. But it's something we hope that folks will enjoy and use. And just be sure to, if you're using the data, please make sure you cite the site you took the data from. So you have some data where people aren't describing the data, and we know it's from a particular sample. So just always be data about citing the data. Just heads up, later on this summer we're using something called the Mechnum preprocess. If anyone has any substance-related data sets or at-risk populations, there we break out about 10 or 11 investigators who are willing to contribute to that. That's with Cameron Craddock and myself, where the data we can process through about 5 or 6 different pre-processing strategies and we'll share. So that will start later this summer. If you have data you want to contribute to that, we can details. Yeah, well, but in order to download it, you have to. So, and really, it's if you join it, is you just pretty much say you want to join it, and 6 to 12 hours, someone reaches out and sees it and clicks it. If for some reason it doesn't mean first doing it, it means someone somehow missed it. That's one of the things. And other than that, just make sure you're logged in. You'd be amazed some of the users in the field who get tripped up or get this lecture from someone logged in. You do not read the parts that's logged in.
So, many questions.
So how much of a behavioral or other data that you will use?
Good question. We gave a core phenotypic protocol to sites. Most people give the bare minimum. We asked for things like we asked for like menstrual cycle, we got information on that, people were fairly limited with that. So it's much more about the
age of humanization.
Oh, yeah, you have age, you have sex, you have evidence, and then there are several data sets to give more into that. So it's been very little bit depending on. We ask people to code time of day, we ask people to code postprandial. I mean, the truth is, a lot of these people don't really log all that carefully, or it's in their icon, and they got nifty, and it's a lot of effort to go through the process, so they're going to do what they can.
Just like before.
Actually, I think that one is going to advise the topic is that's by being a American speaker, like Spanish speaker. Every now and then. So no, it's just yesterday we were having, well, you were having some good and we were talking about this equality of hackathons and how they are originated and how. What are people expecting before they come and when they come, and how it develops? What was it that might be the idea to put it down in words like to finally agile software development manifesto? It just states what are the values for that movement.
Yeah, so this is a very happy day about 1 o'clock last night. So what we started off talking about was more or less kind of there's this notion that when you hear the word hackathon, people that are here may or may not have had a good sense of what a hackathon is when they showed up. So some people have, like, hear the word hack or hacker, and they have a very strong opinion about what that means. It means you have to have a strong coding background that you show up and you're going to be a developer the entire time. But the kind of Brainhack community and OHBM hackathon, the kind of environment that we're trying to support with this kind of an event is not focused primarily on coding. So we want people that have a variety of backgrounds. We want people that are neuroscientists to show up and have problems that they want to solve. And so we started talking about this notion that the word hackathon does not capture what we want to convey. And Roman had this beautiful insight that with agile software development, they have a manifesto that goes through a couple of different things that kind of capture the values of what people mean by agile manifesto. And so you can kind of just take a look at this. It's not necessarily they're not precise guidelines, but more kind of values and just a way of like how you do your work. And so I spent a few times just Googling around to see if other people have had this idea. And so there's one event, or one hackathon manifesto. And this one goes through and it's more about like the tutorial, like how you announce the event, registration, and venues. And it doesn't really capture, it's more like the practical of how you put the event together, but it doesn't really capture the values about what what we want to alter bring that type of event. And so what Roman and I would like to do is get feedback from people on coming up with a manifesto about Brainhack, what kinds of values you want to see people, or what you want to see brought to these kinds of events, and try to break down the barriers of the word hackathon being something that would put people off. And we would like to say that it's an inclusive event, and that people are welcome to join. You don't need to have all of the skills to code as long as you have good ideas and you're willing to participate. So this hasn't had it's a chance to take off. We put down a ton of bullet points because we wanted to share the idea, see what people think. But just like a couple very brief things were, so there's like two pieces that we, two simple things that we start off with. It's just that bring your skills, but leave like titles and egos at the door. So everybody's on an equal playing field. Should be open to receiving ideas from anybody, sharing your ideas, and not being caught up in that. And then a few pieces, no backseat developers or coders or participants in general. And so that anybody that shows up should be willing to participate. And yeah, and so anyways, there's a notion of like having people show up that are just trying to grab hold of a bunch of or a couple coders to just implement their ideas, but it should be more like a reciprocal kind of. That's just idea that we came up with, and it'd be great to feedback as the first impressions of the idea. We just started a little Google Doc, send it on the link on social media pages. So if anybody would like to contribute, write comments here. Are there any comments you have on this idea? Chris?
When my colleagues and I'm wondering if anyone here has ideas on projects that could be done with the same kind of honor, the same energy, the same five that we're done here, that would not be difficult, that would be related to our field, but would require a different set of skills.
I think actually, data analysis projects, for instance. Instead of just coding, there's other data sets. Like, for instance, there's this tallyforest.org data set. That's, I mean, if I weren't working in what I'm working right now, I would just go for it. It's not as a data set. The expertise that we have here, it's valuable opportunity to do that. So yeah, I mean, maybe no coding required, but data analysis it's another really valuable skill nowadays. It's worth promoting.
And I might add like annotations, like so. There's the project. But I mean, right there is a perfect example of one where you just have the expertise to make an article and annotate some brain spell. I think there's another open annotation project. There are a couple things like that where just having the kind of domain expertise would allow you to not necessarily.
Yeah, I think one of the most interesting ones is, I don't remember his name, but he was a 3D artist. Very interesting that he had this 3D about stroke that made that. And there was this, the camera on the top, she was try to check that. Yeah, in the United States in Spitsky. And you have a motion program, which is an abstract program, which you want to build that movie so that the kids will feel their mind and wonder and like rest instead. It's like the kind of interesting what they see still, so that they don't need as much. And so she hired that guy to build a movie that control for things like levels of luminosity, levels of motion. The movie is just really like he's loving he's watching it. And I mean, that's something there was no coding involved at all. Another one was like, Jonathan Smallwood, he's a psychologist, specialist in Ireland. There was this 2 young guys that wanted to do apps for psychology, but really they don't really know their apps. Bad ideas, but they met really super smart guys that you could do that, and that, and that was Brainhack 2012, and in Brainhack 2013 they came back with that brain
from various area, like they got like 200,000 euros to just build their apps and very, those are really stories where in the second one there was something wrong, but I think like one of the key components was the fundamental not good at all. So I mean, really, if you put forward this type of story that you compare things can happen, and just to implement this like that in this aspect. But I see again and again, people learn in job. Last year I sat down with Siasa, in our Facebook for the 3 million avenue, how it does things. And how do you bet, how much do you bet that the developer actually sit down with you for 2 hours and you are stuff? Like, just amazing. And this kind of video, this size, you get like that happening. It has a huge educational value that we ask you to work so far. The hackathon, it's like it's done. There's a lot of attendees. It's like learn about tools and how to use tools. Like that's really something to market much better.
Yeah, 100%. That's I was going to intervene on that aspect of the thing because I learned so much. So I'm so and I think if we could put those success stories, maybe because those are the ones you said, and maybe there are others as well. If you could put those success stories in like a document and like something that grows and we'll be able to show people this is what is happening at those kind of events. If you don't know about that, this is the kind of thing that is happening. That would be really helpful also for the future of the hackathon. And also the Sedge thing is another example of challenges where people do data analysis and stuff like that.
One second. I don't have benefit of all that extension of that is it's really the broadcaster that is giving feedback. So you're not necessarily coming specifically to your some program. You're there to go out and make that feedback responsible for all the collaborations. Maybe you can get together and bring papers or get together and back up things start and follow up.
All right, great. Well, yeah, if you guys looking for the link, it'd be great to hear your comments. It sounds like maybe coming up with some very solid examples of projects that have come out of Brainhack events. Have come up with those so thank you for that.
So we want to put the success stories and the sort of kind of more like the spirit and the in the same document. Maybe there will be a first section on the sort of the manifesto aspect, the second section on the success stories aspect, so that we have the two going to one to with the other and responding somehow.
Yeah, I think that's great. Cool. Next. All right, so next up we have
There's a red light blinking.
I'll show you the pictures later. So, and the word force has been mentioned already. That's what we talked about. We recently released a data set that is the typical example of the fMRI data set. We put people in the scanner, 20 people to sites, and they listen to an audio movie version of Forrest Gump. listed. And the scanner was a 7 Tesla scanner, and we recorded like a nice line of the brain at 1.4 millimeter for the entire 2 hours. And we also had respiratory and cardiac phase, and then we put another scanner and recorded 0.7 millimeter anatomical data, integrated 0.4 millimeters second integrated imaging, so radiographies, and 2.3 millimeter angiography for the fMRI field view, and TI data. That's it. And so we recorded it for a very specific purpose, for the validation of the algorithm that we developed. But the data sets turned out to be so complex that the number of potential ways to analyze it exceeds my imagination. So I'm pretty sure that I can't possibly do justice by sitting on it and waiting for the initial 5 years till I realize that I really can't do it and then throw it away. So we did it the other way around. We published it first, so it came out in the to become prestigious journal Scientific Data. We don't know yet, it's the first issue. And so there is a, I don't know, 12, 13 pages. Yeah, it's called a Nature. The thing is, I used to call it Nature Scientific Data, but actually it is Nature's Scientific Data. Because for some reason it's flipped out that I don't know why. If you go to the journal, the URL starts with nature.com, so we're really proud of it over here. And I can tell you a funny story about the publication of it. So it's a very cheap open access publication venue. And you can decide how much you want to pay. And the price category surprised me in the beginning because you have to pay more the freer your article will be. Which is an ingenious move, I have to say. Right? So if you can have something like a $300 or $200 publication, if you give the publisher, which is the Major Publishing Group, the exclusive commercial publication distribution rights. And of course, I pay the highest price, so it's Creative Commons licensing, for any purpose. Which brings me to the licensing of the data. That's also the same, right? So the data is covered under the public domain indication license, which is summarized by do the fuck you want with it, whoever you are. Right? So if you're a commercial institution, some research, I know, something paid by a pharma company, I know, it's totally fine. You can do whatever you want. The only thing that we ask you is sign a paper, naturally, right? And if you don't do that, you have more serious problems than licensing. It didn't come up. I don't remember to show you pictures. No, it's really bad.
Can you press it? The press.
I think so.
That should come on.
Now it's no longer. Oh no, there's one. So, and we were afraid that that wouldn't be attractive enough. So we are running a contest now. It's called the Real Life Cognition Contest. Because part of the motivation to acquire that data was that we needed a fairly rich capturing of what's going on in auditory related parts of the cortex when they do like real life information processing. That you just magically do.
At the projector.
What is the color of the effect? It's a white effect. We have switched to video. It's really good. Okay, I'll do it differently. This is a hackathon, so we all have laptops. The only thing I will show is the web page. And the URL is study forest, as in forest company, .org. That's it. So, about the, what was that? So we reported that data set because we needed real life condition capture. And we were the first to have that. I think there was a paper, review paper by Uya Song in, I guess, the 20th anniversary issue of your image, where he was talking about that we should have both. Excellent. The man that makes it work. So this is it. I'll show you a couple of images in a second. So there was this paper. He coined the term, I guess, real life condition. And so we have €5,000 for 3 awards that we'll give to people that work towards the goal of being able to work with data that has this kind of complexity. So you don't have to use our data set, we just put it out as a starting point, because not everybody has the resources to come up with data that is suitable for this purpose. So you can use that, or you can acquire your own, or you can do whatever you want that goes towards this goal. And there's a jury. So if you click on the button that says Unconference, it has first the drug, and then what is it about, and it's a list of people on the jury. Some of them are here. And then there's a timer. So, and if you submit anything by November this year, November 1st this year, and anything could be literally anything. This means that could be used for benchmarking existing algorithms. Anything that can work with fMRI, MRI, functional API, whatever you want. So if you let's say you contrast that's something that's worth submitting any new algorithm, of course. Literally anything. It has to comply with a couple of rules first. Whatever you publish, you need to publish it in full. So whenever I need to replicate your tools, it needs to be made available to anybody. And I need to be legally allowed to use it, and I need to be able to replicate the results. So before the jury gets to see your submission, somebody else has to have redone it, except for data acquisition. We're not you need to give people the appropriate licenses, so everybody needs to be free to use that, and you need to submit to a web page that shows your tools, including the primary evaluation criteria, and there's one more. Oh, of course, if you use any data, whatever it needs to be publicly available. Right? So if you put new data out and have that considered, it needs to be not just public, but also licensed in the code so you can find details on their website. So, and then we'll give you money. And as a last point, also if you want that, you can have it multiple ways. So we published it on OpenFMI, and as a result, it's available there in Tumblr form. They have an internet server, which has parts of the data. You can talk to it in ways to talk to internet servers. It's also on Amazon's S3 since a couple of days, and we also have it available via RSIP and via regular HTTP access, and we're looking, for adding more access methods as it becomes apparent with our If you need anything that is not on the website, just write an email and we'll try to make it work. So now, finally, the questions of the data. We have functional data. I show you how it looks like in its full glory. This is the data at 1.2 millimeter resolution. That's the field of view. You can see it there. And non-linearly aligned all 20 subjects to each other. Aligned features of these. It looks like before that, with this website, we're trying to get people some intuitive understanding of what data is available. So we're usually trying to target more than just neural interface. We somehow fail to do that with time constraints. That's how we talk about to explain this kind of data to people that have no prior knowledge about the acquisition of methods. So we could have physiological data, we could validate, and with annotations of stimulus, it's movie, this is the atomic data, and we did some pre-software instructions, so we don't have to do this with in the features, and I will finish with this picture, which shows you that we have completed phase 1 of that project, which is this part. That's the 7 Tesla data with ultra processing. We are right now doing the same thing again with a substantial overlap in subjects. So we're showing people the audio-visual movie with simultaneous eye tracking there, which we will hope to finish by October. And then we are in the feasibility assessment of phase 3, where we want to do simultaneous FMRI, EEG, eye tracking plus physiology in the 3D scale with the scans for 4 hours. If you're still alive.
Any questions for
what about the verification of the analysis or the thing you want to do and you want to find and did you think about that or?
Yes, we thought about that. In the end, we didn't do it. I mean, everything gets excused by time constraints. We had many plans, but we got to a point where we thought it would be more useful to do something than to do it. And if it turns out that people are interested enough in this, we're thinking about doing like a research topic in brain imaging methods. And for that one, something like registered report would be
You do that the audio?
This is podcast, right? No. You know what I'm saying? No. But we have. So the thing is, I don't know if you heard about it, but there is this thing called copyright law. Yeah. Me too. When I discovered it, I was, I was in a movie theater and they told me I'd go to jail for 5 years. So everything that is not discoverable from the DVD release that is specified, we give out as an annotation. And if you talk to me at night, I'll tell you the rest of the story. So no. Are there any questions?
anything else?
Okay, so I don't really have anything specific to talk about. Yesterday I was here for about 2 minutes, and I was asking for volunteers to help me port this website to Flask, and nobody volunteered. Thank you very much, but I did it anyway. So it's done now. You may be wondering, how could you possibly port an entire website over to Flask in like 3 hours? The answer is I came in with it about 95% done. So I cheated. But anyway, so this is still the current version of the website, which is now mostly in Python, but not entirely. So I'm still looking for people who want to help out or add stuff. Many of you will see this before. If not, I'm not really going to walk through this in any detail. But just in brief, it's a website where we've taken a whole bunch of published fMRI articles, done some very basic text mining, extracted activations of what things would look like, fMRI activations, extracted semantics based on word usage, and then related to, and the net result is you can do things like do a meta-analysis of, in this case, 1,200 attention studies, and end up with a map that looks like this. So this is, the consensus estimate of what parts of the brain activate when studies that use the term emotion with high frequency. Now, there are lots of simplifying assumptions that go into this, and it's not very good, but it seems to work okay when you have terms like attention that are pretty broad. There are many components to this. One of them you can see here is an interactive viewer, which I wrote a little while ago, not because I wanted to write a viewer, but because I wanted something that meets my particular needs, but I would like to switch away from it. So I'm talking to Tara to build other viewers with the idea of potentially switching out and switching to something that was designed sort of as a general purpose viewer. So that's sort of one kind of thing I'd be happy to talk to people about. Everyone's interested in working on visualization. There's other things that could be done. So right now, Neurosynth, we heard a little bit about Neurovault from Chris Gordelewski yesterday. Neurosynth will interface with Neurovault. If you upload images to Neurovault, you can decode them on Neurosynth. And it doesn't always work. In fact, it usually never works. But if you're lucky, you pay. And so one thing I'd like to do is actually make it. But it does work all the time. So you can upload an image to Neurovault, and it will decode it for you. By decode, I just mean you will get back a consensus, sort of an estimate of how similar the various maps we have here. So things like emotion. Emotion, population, numbers, all these kinds of terms, and you get sort of a rank ordering of how similar your map is to the maps we have in our database. So that's another just kind of example of application. It's both something you can use for right now, but also you could potentially jump in and help out if you're interested. There are lots of problems with this I won't get into in terms of the underlying data, the analysis, and so on. I don't really have anything specific to say. I just wanted to kind of get up here and just yell at people for not helping that. What the problem is that I get a lot of emails. People email me a lot saying, "Hey, why don't you add this?" And wouldn't it be cool if you did that? And the answer is generally yes, it would be really cool. But this is kind of a big project that I would love to help on. I also will mention, I don't know if this is okay, that I would love to hire someone to work on this. So if you're looking for a postdoc / software development at some point. Any questions, suggestions for anything else we talked about? Oh yeah, sorry, I did think that's what again. So all the code, with the exception of the website itself, which will be open source as soon as I finish putting out this thing, is on the web. So here's the core tools for Python. Actually, everything's in Python, and there's the data set. So you don't actually have to use our tools at all. You can just take the data, which is, as Michael said, same philosophy. Do whatever you want to do. Don't ask for permission. I don't really care. So you have kind of the latest version of the data set, which is now actually I'm going to upload this probably in a couple of days. It's almost 10,000 studies, and a set of features. We tag the articles, so we tell you what terms of the abstract and full text. And you can do anything you want with that. So that's what it is that you can use to do all kinds of analyses without needing to touch any of the rest of the tools. It just comes as 2 flat text files, which you can read into almost anything. Then we have this set of tools, which what we use to extract the data from published articles. Probably not so useful to anyone, but they're written in Python. Also, if anyone wants to play with that. And lastly, the viewer, which is on the website right now, which is sort of a standalone library. So if there are people who are using this and plugging into their own page fairly easily, I wouldn't necessarily recommend it just because I think there's better viewers out there. But this one is at least pretty easy to use and configure. So if it works for you, great. But basically, I don't really want to support it. So use it at your own risk. Yeah. So all the software and all the tools are up on GitHub as they should be. And so I would love people to jump in.
Is there any sense of which of those data in the data set, which of those publications were harder that you think needs annotation?
Harder in which sense?
In terms of extraction quality.
Oh, the track quality is terrible all around. So, so I should mention, I don't know if people realize it, but when we extract activation data, we have no real concept of like what's in activation, what's in deactivation. We guess about the space the image is in, and that not too bad. But yeah, so annotation is probably the single biggest problem. You compare this to something like Brainhack. Well, Brainhack is much smaller, but on the other hand, it's carefully annotated and granulated. So the ideal, I think, is somewhere in between, where you have data that's sort of at least manually vetted, or if not, you have an algorithm that is trying to make predictions that approximate human voters, but scalable. And that's where we'd like to go. And so that's another reason why people want to help out with Brainspell. And I think any kind of annotation we get, we can then turn around and use to train better algorithms to ideally produce that same kind of annotation in an automated way. But obviously, like all of it is sort of it's pretty cool all around. So any help would be good.
So website you choose for your purpose as well, or is there something to be done on the website or to make it better for you to recycle?
Yeah, we were talking about it yesterday. I think actually in some ways I would love to get Brainspell to basically be a layer on top of yours that you can run off, and then it's baked into the whole website. But again, it's the same kind of thing where like you can come up with all sorts of ideas of like what would be ideal and better, but like I don't think anything like that. So any kind of annotation, we'll figure it out after the fact how to make use of it. But like even just saying, it's helpful when people sort of write back and say, in fact, someone just caught a bug in the fact like 2% of the data. And I feel okay telling you that. Like, there's a bug that affects 2% of the data because it's quantity over quality, right? So like there are major data issues and you can find problems that are just like no. So any kind of feedback at all is helpful.
Another one on the viewer thing. It seems that there are quite a few projects in that. There's like a place where people go and say, okay, this is the viewer place, and this is where
we should do that here, I think. Right? So I think there's several people interested, either building groups are interested in getting people to use the viewers. The way I look at this, there's a lot of viewers out there. There's none that I would say meets everyone needs. I mean, there's not anyone that's for everyone, but I think there's, so like my viewer I like in the sense that it has good layer management. The rendering is pretty awesome. There's other viewers that are amazing, beautiful at rendering stuff that don't really handle layers. And so I think we need to all get together and basically identify the major use cases, and we don't have to be reflecting one browser, one viewer to move them all, but just be able to sort of take the pieces we need and maybe kind of adapt a couple of these so that are sort of. It's still is sort of striking, I think, that there isn't really a tool that even I think is sort of as reliable and as that does the stuff that FSL, for example, does on the web. Just surprising. I mean, there's things that do much cooler stuff in terms of visualization, but not necessarily much cooler stuff while still maintaining the same basic features. I just want to see this in thresholds. That's surprising to me. 2014, still don't have that. I hope nobody yells at me or about those stuff. We do have that. But
Let's hope something better.
right now.
So this is really Unconference now. Didn't even put a title in this morning. Daniel asked me to hold a small presentation, and I thought, why not? So I also I do this deep brain simulation stuff, but I also involved in connectomics, so I figured that might be more interesting to most of the people here, and also about the structure-function relationship. And I have just one slide that I found quite kind of cool, and maybe you all have thought as well. Imagine you have two cities, and you have a road that connects them. Then the natural thing that will happen is really to have cars running on that road. Just by having the road, there will be cars going between the cities. I found this kind of cool, and thought this is how the structure of the brain might shape our functional repertoire. And I know that's known for some years now, and I also did some work on the structure-function relationship, and with this global tracking stuff, and compared structure-function in a voxel-wise fashion, so having 40,000 voxels, connectivity, structural and functional compared, and we found out that the default mode network somehow seems to be the region where the structure-function overall agrees the best. So then we thought, like, okay, the structural connectome is more or less fixed, and we can look at it and it stays the same. But how about the functional connectome? You all know that there are these dynamics, and the repertoire state changes over time. So you can, what of course many people do the sliding window analysis, and maybe find that in some regions there might be a high correlation in the first 3 minutes and a low correlation in the last 3 minutes, or something like that. And then you could, for each of these sliding windows, make a connectivity matrix for all of 40,000 voxels, or we always work on voxel-based, so not AEL templates or something, but of course you can do that for AEL templates as well, or FSL templates. But if you take like all the, I don't know, 40,000 voxels of each subject and correlate for each sliding window, then you can use each of these matrices that evolve from that and do graph theory again on it, or like simple graph theory, these, for example, just mapping degree centrality onto voxels, and then you can make a movie. And that I just made that once, and it looks like the states somehow stabilize sometimes and then switch again to different states. So this is voxel-wise degree centrality over time. And I found it quite interesting just to look at it, because you really get the feeling that it sometimes has some stable moments and then again changes again. And I wondered, how can we check out how can we measure that, like at specific time points, measure, for example, how the functional tone evolves, and that usually is being done by tasks. Of course, so not in resting state, because in the task you have these onsets, and then you can average, and then you know in that state of mind, we have this activation at I of G left or something. So we should be able to do the same with the connectome, to have certain fixed time points with a task or something, and then only check out the connectomics, the dynamics in that, and in these time points. And so imagine this would be the functional connectome. We could think that there's a task coming in, and that might modulate the connectivity of some regions, like decrease them and increase some others. And then you could check out how a task shapes the whole functional connectome, like the whole matrix, right? And what's usually being done for this, or like at least some basic measurement which could be applied to connectomics, is PPI analysis. So psychophysiological interactions, I guess most people will know it from SBM, FSL, and we could do that voxel-wise as well, right? Just estimate, starting from each voxel in the brain, a PPI analysis to the rest of the brain, map it back to a connectivity matrix, and then we could get a task-selective relative connectivity matrix. So how the task shapes that, like the whole matrix in one time point, or like during the task. And we did that with actually the SBM example data, which is quite old and very well known. It's about these moving dots, and in both conditions you see the moving dots, the exact same thing, but in one condition you just are told that you should attend or like focus on the motion of the moving dots. Right, so yeah, then you have a contrast where the visual stimulus was exactly the same, but just instructions different. And we did it, and we found that, first of all, the regions that you can see is just one single subject data now, but the regions that you see that show the highest degree centrality, so task-related degree centrality increase. So in other words, regions that by the task get more connectivity to the rest of the brain are the regions that we would expect. So we have frontal regions and parietal, supraparietal regions, and also visual regions. I don't know if anyone is interested in attention, but that's really like visual attention. That's somehow what you expect. I did this more on methodological reasons, so I'm not an attention expert at all, but I found it quite nice that these regions really show the highest connectivity increase, and also can be seen in a standard GLM analysis. And then again, you can even see that the connectivity seems to be directed. That's actually the reason why I wanted to show this, because I don't know why, but the data shows it. Like, it seems to be directed. So we find a lot of connectivity frontal to the supraparietal and supraparietal to visual, but not the other way around, which could of course be interpreted as this top-down modulation, that attentional areas like frontal areas somehow, if you attend to a visual stimulus, modulate the visual cortex. But I wouldn't have expected that the methodology, that like the PPIs would really show that, since we have this slow time resolution, and of course we have deconvolution steps, but I'd be happy to discuss these directionality things. And it's also a poster at OHBM, so there would also be time if you want to over. And yeah, that's already it. Maybe if there are some minutes, anyone has a suggestion.
Any questions?
There's lots of interest in this type of like studying analysis. At some point, I'm just wondering, there are lots of people models, in fact, describe what we know. We have this like covariance matrices. We feed the data. We have n square parameters for n different. And we ask a lot of this observation, and the experiment is very simple there, but boxcar functions. Is slightly different modeling from shapes. And so, when you have boxcars and stars, you have super high correlation network where it starts, and you plateau, and the correlation goes down, and then it goes down. So if you do a simple, like, linear superposition model, you're going to get those cool sliding window correlation moving around, and all that reflects is those, like, sample training of data is like a method that's called total activation, developed by, I think, Randall Labs in Switzerland. And they've shown that, well, basically they try to estimate the paradigm in one system data. So really we explain those, like, task, state-based patterns using a simple, like, linear model decomposition. And so I know also the work of SQ trials in like the net, 8 hours of acquisition on several subjects, and they averaged many trials. And they were able to show that the task populations first are present in 96% of the brain, and second are extremely variable in shape across brain regions. To use a simple sort of paradigm that I described, about simple boxcar functions, you have to let the actual, like, neuronal activity in the boxcar within very system-specific, region-specific. So you can get this very network timing modulation just because of the complexity of the response in the spiral voltage that shows that is a simple model task. So I really think it's just like this kind of simple evoked information. You can explain a lot of what similarly there's more, and you actually need a connectivity model for it. But just a simple model and explaining here to generate this type of observation. And we will discuss more.
Yeah. So, but just to clarify, like, this last picture was not a sliding window unless like a DPI.
Yeah,
like over there, okay.
But it's like very same. It's
Yeah.
in place of a single value. And this is providing the example of the tool of the this one, just with variations.
Well, this is similar lines, but I'm just wondering, how is that trouble to interpret whether the reason I'm telling us? It's a cool picture and neat and seems to come out, but then when you start describing what that is, it's difficult to know how to, going on. One thing that comes to mind is how does it compare to the actual activity? You see more activation in these regions that are more recent down. Is that basically what you're finding?
It's really similar, but it's also a bit different. So it's I would be surprised if it would have been like completely different regions. But that's exactly what I was interested in, like the relationship between activation, whatever activation is, but the SBM or the neural HRF activation and whole brain connectivity change. Because I think a region that is active, like we see as active in the fMRI, is maybe a region that is just highly connected in that time. And so, of course, it could be just an artifact that we see in the PPI analysis doing box-wise that is just activated regions that also get like more statistics in the PPI. But then again, we see this directionality, which also somehow fits our thoughts at least. So I know this is really preliminary. It's only one subject, and we now try to do this on a group and do statistics on it and stuff. But I just thought maybe a bit on. So yeah, thank you for the attention.
All right, now up next is this here.
Okay, so I'm just going to talk briefly about an ongoing project that came up with, in several discussions. So yesterday with Sunai, Tony Moves, and so it's related to what you shared about the SAG Brainhack challenge. So for the past couple of years, I've been working on a method to test association between connectivity and a threat of interest. So basically, it's a very simple linear model at group level. So you estimate connectors for every subject, and you're going to regress out a number of variants of interest and estimate statistical parametric connectors and test that with standard statistics. So you get a t-stat. If you're interested, you have contrast on edge, you're going to get a t value for each connection between pairs of regions in the brain. And you have p-value, you have an enormous multiple comparison problem. I'm going to just cut all of that down. But the main idea is that we generate parcellations, and you do it with length scales, like the number of networks you're asking. And so basically, you get a connector that's very crude. You scan network up to like here I've tested into a scale of 500. So just that those connectors are represented in real size here, and you can see that if you have 10 networks, it's just a tiny fraction of the multiple comparison you do at scale 500. So essentially, you're going to run this type of statistical parametric connector analysis at a bit scale, control for the full discovery rate for each scale independently, make like an obvious test that there is some signal, and then don't worry that you tested many scales, because if there is some signal, the FDR is a procedure that scales well, in the sense that if you have 5% false positive everywhere for every connector, you have also 5% false positive overall when you combine your connectors. So that's like just a very quick outline of this procedure, and so I wanted. I mean, we've done a bunch of evaluations, simulations, whatever. That's not what I want to talk about today. Kind of my lab, I started 3 years ago with the idea of applying this type of data mining techniques to Alzheimer's disease. And so we finally have data, because Alzheimer's disease is like, I think we need likely lab to be more involved in Alzheimer's disease. So there's not enough like big data sample out there. But so there's now we get this data set together, it's pretty nice. So Ali has added resistive MRIs in a sort of their sites. So all the physics scanners are now doing resistive MRI. So we have about 150 to 200 subjects from about 12 scanning sites in there. And then there was a number of studies in Montreal where principal investigators agreed to share the data with me. Not with the world, I'm working on that, but at least I get it out. Maybe I need to be more like with that anyway, altogether we have like a very nice sample size. We have about 115 elderly normal subjects, about 120 patients with microcognitive impairment, which is a condition that puts you more at risk of developing a dementia of the Alzheimer's type. And people with Alzheimer's disease, which means with dementia of the Alzheimer's type, if they die inside their brain, you might have Alzheimer's disease or not. But that's a clinical condition that people think about when they talk about Alzheimer's. So anyway, at this stage, I'm interested in very good analysis just to distinguish those 3 groups with the type of connector-wise association study I just described before. And my issue is that I have lots of, it's a multi-site data set, really. And I thought it would be super well designed, at least to count on Andy, but it's actually not. Or I mean, I'm going to get into that, but it turned out that it is a real problem. So this is an ongoing study with a PhD student of mine, Angela. And so something we started doing because I develop methods, so there's lots of iteration around when we do the analysis, and I also do exploratory analysis, so there's lots of exploration around. So I want to document that. I mean, I put my code on a version controller, but I don't have a version controller for my analysis. So what we decided to do recently, and I'm actually pretty happy with the way it goes, is that we're using Google Plus in the lab as a lab notebook. So
Anyway. Yeah. Okay, so that's my Google Plus account, so that it's going to talk to me. We can just like maybe hide that. So here I've looked for hashtags. It's next to the name of my lab. Idiot is like the name of the project, and then I have basically a timeline of like what's been going on in there. Generally, we post like which script we used, why we did it incrementally, like snapshots of preliminary results, stuff like that. So really, you have the whole history of what we've been doing around this data set, try to understand like what's going on, and you can actually export that as a JSON file and eventually publish it. So if somebody wants to parse that, have fun. So here's the post like. So that's what's going on when you compare a patient with MCI and controls. So you have like a lot of findings where you sit in the ventral medial frontal cortex. It's actually something that came up at, I don't know, maybe scale 50 or something like that. So you have like 50 big networks. So it's not like a post-surface analysis here, but you can still run them as maps. And so here I think it's using just the temporal lobe here as a seed. And you see this overall decrease in connectivity with other regions. So that would be indicative of fairly massive effects of MCI on connectivity with temporal lobe and frontal medial cortex. So with patients with dementia, compared to patients with MCI, we also have differences with maybe the temporal lobe, this decrease in connectivity for demented patient with the posterior part of the default mode. So something that it looked like it made sense. But here it's an analysis where we look at disease effect without modeling the sites at all. We just do like a crude analysis, just patient managed control. So something I got concerned obviously because it's not site data, maybe there's site variance and like how does this affect me? Well, it turns out first there is a huge multi-site effect. So here all I did is pull like the control and the patients with MCI and compare my admin sites with my Montreal sites. And with a seed that was somewhere, it's described in the post that just before. It's a seed that's in the lateral prefrontal cortex. And I mean, you've got those massive differences in connectivity between the images generated at the two sites. And so what happens in that case is that ADNI2 has about 2/3 of the subjects are patients with MCI, while the Siemens Montreal study, about 2/3 of the participants are controls. So when you do control manipulation MCI, you also do to some extent ADNI minus studies we can in Montreal, which happens also to be Philips scanners against Siemens scanners. So I mean, we get a bit of a problem here. So what we did is try just to model Siemens and Philips sites, and I mean, this did kill some of our results. Not all of them. So those are that shows which seed in the brain give differences between those populations, at least for two contrasts that survive. But now we've also tried to go and model every single site, and it turns out that some sites have like 40 subjects, others have like 1. So it's extremely spread out, and also it's super unbalanced. It's like not all populations are at every site. So when you actually model site by site, first you have to filter a lot of your data set, you just can't fit because you don't have all of the populations that present, and then you lose all of those effects. So I was thinking to do some kind of like random effect analysis. I've also tried some of the normalization stuff that was published by Chiogan and the postdoc with Macmillan. Kind of take care of those. The normalization, I'm not too sure still how to implement, so maybe that's something we should discuss. What I implemented didn't look right. The random effect analysis I tried to get, it's not available in MATLAB, there's a very good code that developed at Kit Forces that I could have adapted here. But I mean, since Kit died, this code was kind of preliminary. There's a library in R, but it's kind of complicated, and I was working on it, and Tom told me to just like forget about it because you can use that because then you have enough sites. So I now forgot about it. So I just saved probably like a bit of hard work and bitter frustration. So Tom proposed me to the idea of just computing the different multiplication protocol per site and just testing the average of that. So it's apparently a statistical technique from more like meta-analysis work. So I'm going to try it out. And just an outline of the joys of working with multi-site data in the ensemble. And thank you for your attention.
Any questions for Pierre?
One side.
That's music that have to.
Who we have up next? Josh.
The form will go out at the very end. And people can just hit one of this. There's like 5 or 6 questions.
People would feel like there would be about 5 or 6 questions that were sent out as part of the evaluation. Yes.
Daniel, yeah. And one brain score tagging exercise.
I was thinking, why not? Yeah. We do a brain cell tagging exercise before the flow. Oh, is it written? Hey, Ribbon. How's it going? So we could do a brain spell like a morning kind of the way one would do, maybe some jumping jacks. We could do a brain spell tagging exercise. Like a tagging exercise. In the morning, it's 2 minutes of a tagging. I have tried to like activity calculation application, or I can so if you have. I think I come to an iPhone. Wow.
Now you all can see it on
It's on the scale. Scale.
So I'll try to keep it short. So this has nothing at all to do with brain science. This is sort of a provocation. Okay, so this is a very rough sketch for an installation that I'm doing in Delhi next year, maybe about 11 months from now. And what you're looking at is a kind of a collaboration sort of a conversation that's been going on now 2 years between me and my friend Rahimi Share, who's an artist based in Delhi. So Rahimi has this project where she, it's not this project that's been going for about 4 years, where she samples video feedback. You know, she puts video cameras up to each other and samples the distortion. And then she cuts it up into 1,000 little subsequences and resequences it into these biomodels. And she's been showing these for a while. And in here, I can show you what one looks like or not enhanced. But then we started talking about, well, how could we make them more interactive? You know, so what we came up with is that these are basically static. Videos of about 5 minutes, and they're shown in a gallery, generally in pairs. And people can look at them. But they don't really reach out to you. And we wondered, well, could we make them generative in a way that would really engage visitors? Create the same kind of feeling of kinesthetic empathy that you get with in art performances where there's actually another human being there. It might only sound generative art to me really, it might be really cold. And at the same time, I was interested in exploring how our habits of motor resonance and kinesthetic empathy are changing as we spend more and more of our time with more and more other than human moving presences, especially on So, yeah. Let's think. Cycling now. Okay. So I'm coming to the point very quickly. But basically, we're using the videos, and then she sends them to me also separated. And I attach an oscillator to each separation. At the moment, the oscillator pulse is represented only with a brightness enhancement. And then there's also some distortion that we're adding. And eventually, this is going to become, the oscillators will start to train to each other, and then to oscillators in other projections, and then also to visitor activity through web cameras and the audio center. The point of all of this is that I kind of accidentally, because working on this, accidentally created a lot of revenue. And so because you can, I'll give you a brief illustration of what I mean. So all of the stuff, all of the oscillators that there along with the distortion, stuff like that, are controlled through a configuration file. And you can actually modify it and reset it without restarting the video streams. And so you can play with the settings. Like, so it says, maybe go seizure inducing, and if we want to go faster, turn off the distortion, go down. So you can do that, and then you can also modify the shader. So basically, there's a controller here which normally is written in processing. We started out in Cinder and left it back to Cinder. Most of the work is done in a GLSL shader, and so you can modify them and then reset without reloading the video on the fly. And so this creates a very interesting way of exploring different strategies of visualization. It makes the programming process itself more interactive. So getting back to what we heard at the top about introducing agile method into development for brainwave. Again, my provocation is, could live coding be useful in the kind of stuff that you guys do in your everyday lives as developers? Right? Is there a place in for example, in pentatonic visualization, or is a style of analysis where you're actually modifying the analytic parameters while you watch the while you watch the analysis and the visualization unfold. And if so, how would you start to fold live coding into it? That's basically all I have to say. If you're curious, I can offer more background about why we do these, how we do it, and what the aims are. But yeah, that's pretty much it.
Questions? Yes. I think there's absolutely a place for tools like this, at least so I can imagine neuroanatomy. When you look at what we do with the brains, when we visualize them, basically either with video slices or with skin learning. But it's very limited in terms of the interaction compared to what can do a real neuroanatomy. So a neuroanatomist could, for example, pull the opercula of the insula and look inside the brain, or separate the hemispheres to kind of have a look at the corpus callosum, or even they can even take fibers and big bunches of fibers and pull them away to see how the things connected. You compare with that, that skin stuff is so thin. And I think that's some kind of tool like this that would allow us to interact with your data as you would interact with a real data.
So you're adding more degrees of freedom to the interface, right? So there's a way in which adding the degrees of freedom to the interface is coming out from one end and then making it possible to reprogram the analysis. Is doing the same thing from another end, right? So maybe at a certain point you're adding so much flexibility to the interface that it becomes more of a reprogram, right? Where you're adding
Yeah, because you could kind of add new interaction with a tool, or you can have some kind of text in
right,
where you could review processes or the conditions, stuff, and you know exactly.
And since a lot of people here work in Python, there actually is a Python-based environment that will allow you to do a stack called Nodebox, where it's a path programming environment similar to Google or Mac, but it also lets you insert arbitrary text-based components. Kind of interesting. And the newest version is it's GL.
Any questions? Except for that.
Hello, I'm Hansen, and today I'm here to introduce two of the computative method in FMI, Sparse GRM and Spark. It's still in the developmental state and on fibers for clarification and analysis. So, this idea has been started from this kind of sparse nature of the method, which has been observed in neurological recordings in using remote structure or visual cortex like that. So basically, simply, it's like that. You record the electrical signals in neurons in the visual correa, for example, here. They show the subject typical understood picture or whatever it is, like spiders, packages, something like that kind of features to them, and see if the neuron is wired to a specific picture or a specific concept or specific writing of the alphabet, something like that. And interestingly, only a unique neuron is wired to the Jennifer Aniston's picture, but not for the picture of Jennifer Aniston with breath. So they have suggested this idea of selective firing networks to the brain. And also, this kind of sparse coding for primary visual cortex single cells has shown that the receptive field of our visual neurons are really specific to a simple pattern that can represent the basis of the complex mental image. There are many kinds of functional cognitive analysis, like seed-based analysis or independent complement analysis, and they're really good, pretty good method, and they have pros and cons. But basically, they require, for example, ICA requires the assumption of independence of the stimulus, and then she has demonstrated the independent problem analysis is not really select for independence content for MRI. It is not really appropriate, and sparse feature of the gradient is more proper for analyzing the gradient MRI. So based on this idea, we have developed a sparse GRM, which can represent the time series in the boson as a linear combination of a few number of editors. And this dictionary is obtained from the whole grid. So we obtain the whole grid dictionary from the whole grid and select only few editors from this dictionary to represent a sequence in each boson. And this selection is represented in the classification vector as shown here. So this number of non-trivial elements in S vector is actually sparse. So this is called sparse GRM. And the previous implementation of sparse GRM demonstrates that by using this kind of few number of items as a regression in sparse GRM model, like here, I will pick. So after pre-processing, we do the sparse dictionary learning to train the dictionary and corruption metrics from the data, and then do the inference based on this a few number of regressions in GRM model. So this, here the statistical activation map shows for block paradigm for right finger second task here, and they show that the B is a sparse GRM activation map, and A is the canonical HRSPM map, and CDE is the ICA. Besides special ICA, we implement special ICA with best ICA, and the E is a PC. So we demonstrated that sparse GRM can extract the activation of MRI in the case of task-based analysis. And then now we are currently developing Spark, which is pursuing more reliable extraction of the networks, and also we can analyze the hub organization in the brain, not only extracting the resistive networks. So we are currently applying this method to resistive application. So that's why I'm talking about this. So here, the idea is the same. In sparse GRM framework, we're gonna put a set of boxes to each resistive networks. And for some of the boxes, there are many of the networks will be involved, while other boxes will involve only one network or two networks. But some of them, a few small number of them, will be involved in many number of networks that we can take this as a very functional hub in the brain. So this is my idea. We are going to do to increase the reliability of extracting the consistent resistive network and hub structure. We're going to resample the original data set using the bootstrap analysis, so like 300 times, and we apply the sparse digital learning for each replicated data set to obtain the spatial map of the resistive networks, and spatially clustering them to get a final stable any number of resistive networks, and especially to get the final version of this agent maps and a hub map, which counts the number of networks involved in each regional activity. So in the simulation stage, it's just saying that by mixing these three signals, we can decompose the signals into three box signals and noise component very accurately. And also it shows by using the bootstrap analysis, this is very reliable extraction of the KNet compared to single level KSEB based GNet. So this is the consistent resistive networks that we have obtained from one subtype of our preliminary data set to the extract motor network, left part of the collateral network, visual network, the auditory subcortical networks, T4 network. So the problem we have now is that some of the atoms are included in the physiological world. So when we come to the K-map, K degree, the number of networks involved in here, it's not exactly the complete set of networks. It also counts the physiological noise in this by the K-map. So it shows that PCC is one of the hub in the brain, in the functional brain, and PCC is involved in this kind of 9, 11th, 4th, and 19th network compared to others. And then this may be really useful to analyze. We found the hub region in the brain, and now we know using this spark analysis, now we know what is in there. So this is very specificity that previous conventional method cannot provide. And we can directly analyze what is in there in the hub region in the direct relationship with this HMF that has extracted using our method. And it has a past reliability. We are testing it, and I want to ask you, Cassie, that if I see some kind of high degree of visual area, not only in the PCC, so if you have any knowledge about this, please evaluate why it's happening in the area. Maybe it's, I don't know, maybe it's a physiological, maybe something that I don't know about the science anymore. So, thank you.
So I wasn't sure how you select the sparsity.
The sparsity level is agreed by maximum minimum discontinuous criteria. So for each box we compute that, by varying the K value from 1 to K, we do the same analysis and set up the best trade-off to
the other question I have is, so how do you go along with the implementation, and how do you sort of, what's your workflow? You're trying some method, you're implementing something, you're getting some results. What's the workflow such that at the end you're not like selecting the methods for your own data, and like you have some train data and test data?
No,
and also what's the implementation?
From one data set, I analyzed this, I trained the dictionary action from this data and get the final HTML so no training data.
And the implementation, is it?
It's on MATLAB. It's obviously GUI,
Oh, you have to set the software to finish.
It's free to one of my colleagues to have the reviews and try
Any other questions? All right, great. Let's thank our speakers.
So everybody's going to get an email helping out. If you don't receive an email, let me know, because there might be something wrong with your email address the way it's entered. We want to do a brain spell calisthenics.
Yeah.